a whole brand new article. Here we have an EVGA 3090 graphics card. This one is the FTW3 Ultra. And the card looks something like this. That's one big card. And the card is still going for about $1,400 on Amazon. It's not a cheap card. 24 gigs and all the bells and whistles. Let's read what the customer wrote. Graphics card suddenly blacked out while editing photos. The computer boots, but no signal from GPU. One of the GPU fans sometimes briefly turns on, then dies. So the card has issues. Hopefully we can help out the customer and save this nice card. What we're gonna do, like always, is we're gonna do a quick visual inspection. Make sure we do not have any blown components, any knocked off components, any burn marks, any cracks. And after we do visual inspection, we'll proceed to test all three 12-volt lines. 5-volt line, 1.8 volts, PAX, memory, 3.3 volts. The PCIe connector, the lower 12 volts. Measure fuses. Before we start the video, I want to give a shout out to our sponsor PCBWay. PCBWay is a China Shenzhen-based PCB manufacturer and printed circuit board assembler with more than a decade in the field of PCB prototype and fabrication. They offer a wide variety of services including 3D printing, CNC machining, sheet metal fabrication, and much more. PCBWay is committed to meeting all your PCB needs. They offer quality, on-time delivery, and competitive pricing. 1 to 2 layer boards starts at $5 with 24 hours turnaround. Get an instant quote by visiting PCBWay.com or click on the link below and make sure to check them out. As you recall, per the last video, we had a short circuit on one of the 12-volt lines, and we were able to tell which DR MOSFET was shorting out because of a blob that squeezed out. So normally what I do is I look at the MOSFETs, DR MOSFETs, just a quick visual inspection, and see if there's anything obvious. I did not measure anything on this board before recording this video, so everything is being done in real time. Big Boss always does the initial inspection, whatever he does. If I do work on the board before recording a video, I usually mention it. I tell you that I tested this before recording, and here's what I found out. To me, if it's a fix, we get paid the full price, the big amount, or if it's a no fix, we get paid the bench fee, which is the minimal amount. And the minimal amount, the bench fee, barely covers the time and work and the overhead to work on the card. Big Boss has to disassemble the board. I have to work on the board under the microscope. I have to give it back to Big Boss to reassemble and test. We have to communicate with the customer to make a payment. The customer may have questions. He communicates back. We communicate back to him. All this is a waste of time. We rather fix it and get paid the full amount. Some viewers mentioned that for us, we just deem it a no fix and we get paid the bench fee. It's a win-win. It's not a win-win. If we get paid the bench fee, we're not making money because we're spending the time, and in the shop here, time is money. And we rather fix the device because we get paid the full price rather than the minimal price. If we want to get paid the minimal price, then we would close the shop. Why open the shop? We're not going to be making any money, and the money that we're going to be making from bench fees are barely going to cover the overhead that we have in the warehouse here. We have a big warehouse and all the expenses that follows. So if we are living off the bench fee, we're not going to make it. The bench fee is only a minimal fee to compensate some of the time spent working on any device, and there's a bench fee for everything. Even if we look at the device and we do not do anything, we spend the time to open it, we spend the time to work on it, we spend the time to put it back, to communicate with the customer. If we do not charge a bench fee, then we're going to get a lot of junk in. People are going to send their junk left and right. They know that they're not going to pay any bench fee. It doesn't work. It used to be when we started the business 12 years ago, we did not have any bench fees, but that quickly changed. If you are starting out new in business, you do not want to charge a bench fee. You want to build your reputation, and you do not start building the reputation the wrong way. Once you have the reputation, then charging the bench fee is no problem because people trust you. So far, I do not see anything wrong with the board. Data lines, we do not have any missing caps. And I see that a lot on many graphics cards where we have a ripped capacitor, and that can cause the card not to work. Beeps 6 times on our motherboard. So far, I do not see anything unusual. Unless I missed it. And people, newbies may be wondering, what's this? What's this? Is that liquid? It's not. This is usually from thermal pads, and it's not liquid damage. You see this on every single graphics card. Okay, so nothing unusual. The card looks very good. And while doing visual inspection on the card, I gave you a lecture on bench fees. Win-win situation. You benefit, and I look at the board. Let's measure our 12-volt rails. We have 3 of them, 1, 2, and 3. I want to see if we have a short circuit. Very common on graphics cards. I think 50% of the cards that we get in have a short on the 12-volt lines. Some people in the business, they say, how come I never get any video cards with 12-volt shorts? How should I know? Measure here. 0.46, perfect. 0.47, perfect. And 0.47, perfect. And of course, our fuses are gonna be good, both ends. If we do not have a short on the 12-volt line, then there's a 99.99% chance that our fuse is good. .34 voltage drop, 0.357 voltage drop, and I'm measuring in diode mode. Let's go to ohms mode. I want to measure our 1.8 volt line. We should have about 200 ohms, 212 ohms, and we do 212.8. So there is a very good chance that our core is good. We're going to measure our packs. We should have around 6 ohms, more or less. We do not want to see 1 ohm, 2 ohms. Right now I'm reading, packs is reading a bit low, 3.5 ohms. Actually 3.1 ohms. That's half the value of what packs should be. But we're not going to assume that core is bad. I mean, the value is low, 3.1, but it's not 1. It's not 0. It's not 1.5. 3.1, maybe. Let me plug in the card. We're going to measure voltages. Hello? Yes, I thought the microphone was not working, but I put fresh batteries in this morning, and I learned to replace the batteries every day. I do have rechargeable batteries, put the old batteries in the charger and take the new ones out and put them in the microphone, transmitter, and receiver. I have the card plugged in to the PCIe adapter. Now we're gonna plug in our 12-volt cables, 3 of them. Big Boss is working on something and he's looking for a donor laptop. Good luck finding one, because we have thousands of donor laptops. We organize them in shelves. Acers, Asus, Lenovo's, every make and model. But still, the shelf that contains Asus, we are organizing them Asus 13-inch, 14-inch, 15-inch, 17-inch, the thinner ones, the bigger ones, so that we can find what we are looking for quick. Otherwise, even if we narrowed it down to Asus laptops, the Asus laptop shelf, we still have to look, because we have a lot. Okay, so I have all 3 cables connected. 1, 2, 3 down here. PCIe adapter. And we're gonna measure. Meter in voltage mode. We're gonna turn on the power supply. And you're not gonna be able to see a thing, but you're gonna have to trust what I'm telling you. 6 beeps is a good indication that the card is not working. Do we have voltages? 12 volts, the first one. We do have 12.25, 12.25, and 12.25. I do not know if it's better for you to look at me or to look at the board. Which is better? Let me show you what I'm doing. So I measured the first 12-volt line right here. We have 12.26, 12.26, 12.25. We're good. If we go a bit down, measure here, we have 5 volts. Perfect. We go a bit down, we have 3 volts. Let's check our 1.8 volt line. Right now we know that we do not have a short on this line, so very likely our core is still okay, even though our PAX is low. So 0. I turned it off, turned it back on, and I'm gonna leave my probe here. Are we gonna get any readings at any point in time? No. So we are missing 1.8 volts. We are missing 1.8. Now, if we were missing 1.8 and the reading on this inductor was low, then we can safely deem this card in no fix due to a core issue. But the reading was good here, 212 ohms. So we know that we do not have a short on our 12 volt, on our 1.8 volt line. Let me turn off the power supply. We're gonna jump over to our PAX line. And we're gonna measure. Are we gonna get a 1 volt reading here? Power supply on. And 0. The reason I turned off the power supply and back on is because I want to see if at any point in time we get a reading, even for a split second. Turn off the power supply. And let me take a look at the 1.8 volt area. The inductor area right here. I just want to see if there's anything unusual. Then we're going to flip the board, measure from the back. I do not see anything unusual here, just based on visual inspection. But if we flip the board, I've worked on a lot of FTW3s in the past, and I know on the back we have a fuse. Meter in ohms mode. And we're gonna measure from here to here. And look at this. We are reading 325 kilo ohms. We should be reading 0 ohms. We're not even in the ohms range. We are in the kilo ohms range. So we have a blown fuse. Let's measure in diode mode. We're gonna measure one end of the fuse. And we have 0.04 voltage drop. Actually, it's going up. 0.15, 0.17, 0.22 voltage drop. If we measure the other end, we have a dead short. We should not have a short on any of the ends of a fuse. Never. You do not short a fuse to ground on purpose. So right now we have a short circuit on one end of the fuse. What does that mean? Right now we have a short circuit on one end of the fuse. So that tells us that we have a short circuit somewhere on the board. But where is the short coming from? Is it our core? I highly doubt it based on the PAX and 1.8 line reading. What we're gonna do is inject voltage at the fuse. And we're gonna monitor the board under a thermal camera and see what gets hot. It could be one of the DR MOSFETs on left side of the card. You know how we always tackle the DR MOSFETs on the right when we have a 12 volt short? But on this card we do not have a 12 volt short. Usually we tackle those DR MOSFETs, but we have another set that we have here. I noticed anytime we have a 12 volt short down here, it has to do with those DR MOSFETs. And if we have a short on the fuse on back of the board, the one that we just measured, it could be likely that we have, you know, one of those DR MOSFETs may be bad. That's not always the case, but based on my experience working on those cards. Don't tell me the thermal camera battery is dead. Because if the battery is dead, I'm gonna have to recharge it. Yeah. I'm gonna have to stop the video, recharge it for like 10 minutes. I'm still using my old Fleur E60 thermal camera. People ask, why aren't you using the UNI-T thermal camera that you sell on your site? Why would I use another camera if I already have one? I've had this camera since like 10 years ago, and Fleur E60 is one of the best cameras in the market because of the FPS, 60 FPS on this one. But to be honest, not much difference than the UNI-T if you take away the FPS part of the camera. I'm gonna have to charge the camera. I'll be back. We're gonna start by injecting voltage at the shorted end of the fuse. 1, 2, and 3. See, end of that short is beeping to indicate that we have a short. And I'm looking for any heat spot on the board. And it's gonna be difficult, or heat spot may be very minimal. So we have to keep our eyes open. Look at this area. Look at this area right here. Okay? See that slight heat spot? Heat looks like it's coming from back of the board and not the front. So what we need to do is inject voltage here, and we need to flip the card. I mean, I'm holding the camera with my hand. I'm gonna inject voltage like this, and I'm gonna grab the board. I need 3 hands for this job. 3 hands. See it? Right there. So it's the third one from the bottom. Okay? Third one from the bottom. 1, 2, and 3. We are getting a heat spot here, and that's likely the component that is causing the short. I want to verify this one more time so I do not remove the wrong component. We have aluminum capacitors right next to every DR MOSFET, and applying heat in this area is not easy because those caps can pop. So we do not want to remove the wrong DR MOSFET. I want to be 100% sure, but I was able to count third one from the bottom. So 1, 2, and 3. That's likely our culprit right here. Let me inject voltage one more time, and so if you look at the cap on the left, we can count 1, 2, and 3. Yeah, we're gonna go for DR MOSFET number 3. I do not even know what type of DR MOSFETs are being used here, so let's clean up. By the way, the Asus graphics card that we worked on last, we did get the DR MOSFET that we did not have in stock. I installed it and the card worked. I do have a video on that one, so I will post it soon. BL and 0, we do have that DR MOSFET, great. So this one we're gonna be able to finish right now. Whatever tools we are using on our bench here, everything from Flux, braid wig, this amazing microscope, articulating arm, the UNI-T thermal camera, soldering stations, hot air stations, everything can be purchased directly off our site. All items are in stock, unless of course the item is not in stock. Log into NorthridgeFix.com, click on shop, add to cart, checkout, pay, and we almost always ship out same day. For all those who have ordered from us before, you know how fast we ship. Feel free to leave how your experience was like down in the comments. Purchasing from Northridge Fix. With exception to those 1%, of course, that will complain no matter what. My experience was 9.9 out of 10, but it's not a 10. Okay. So we must have done something wrong with the 0.1 that you're talking about. Some people just cannot give a 10. I expected the package in the morning, but it came in the afternoon. Okay. Good to know. My articulating arm has a scratch on it. The guy ordered from Europe. And the articulating arm for the microscope is like, I don't know, 50 pounds, the weight. So you cannot use it if it has a scratch on it. I mean, all our items are brand new. If there's a scratch, it's from the factory, but it's not a big deal. It's an articulating arm. I mean, I hope you're not taking a picture with it and framing that picture on your wall. But even if you are, what's the scratch between friends? The guy was requesting a whole brand new article. The cap popped. I told you, those caps do not like heat. What can you do? We're gonna have to replace the cap, no big deal. Look at the way the cap looks. I mean, it cannot be good to breathe that substance. It smells like fireworks. 9 out of 10 times we do it without the cap popping, but the safest way to go at this is to desolder the cap from the bottom, finish the job, then solder that cap back on. Most of the times, those caps do not pop when you have a shield over them, but this one did. Let's desolder the cap. And I was not wearing goggles. It could have been my eye. We're gonna apply low melt solder. See how that pin moved? And the cap is out. Bye-bye. Let's put some flux. We removed the suspected DR moss. And we're gonna check, do we still have a short circuit at the fuse? Now if we do, then bummer. We're gonna have to test all over again. Part of the job. Do we still have a short circuit? 1, 2, and 3. And we do. We still have a short. What's going on? Just look up how many videos I've done pinpointing where the short is coming from, and almost always we get the right component. But today, the board want to play games. We got the wrong component. Let me test one more time. Yeah, we still have a short circuit. So we're gonna have to inject voltage again, and we're gonna monitor the board under a thermal camera, but the board is still hot. So we're gonna have to wait for the board to cool down a bit, and we will measure again. Oh. Okay, wait a minute. I think we are bridging, you know, the cap that we removed. I did not clean up yet. Okay, that explains it. Let's measure again. Yes, we do not have a short. I was surprised that we got the wrong component. I was almost 100% sure that we got the right one, but we did get the right one. We do not have a short anymore. I forgot to clean up here, and that's why we had the short. Those two pads were bridging, but now we do not have a short circuit anymore. Great, awesome. See? But the fuse is still blown, so we need to replace the fuse. We're gonna have to replace the fuse, the DR MOSFET, and the capacitor. The capacitor that popped and almost took my eye. Amtech wipes to the rescue for a better than factory finish. Let's flip the board. And we're gonna grab a brand new BLDR moss. I do not know if we have this DR moss on our site for sale or if we have the fuse, but if we do not, I'll make sure they are posted for those who are in the same type of business and need those components. You do not have to struggle and look everywhere to find them. You can just buy everything from one place. Perfect. Very nice. And now all we have to do is replace the cap. Most video cards, they share the same caps. Not all of them, 270 16 volts, so we're gonna grab this one. Let's desolder from the back. And the power of low melt solder. Just push it down, and the cap is already on the bench. The cap is already on the bench, right here. That's the safest way and the most practical way to desolder a cap from a video card, from a 12-layer board. Low melt solder. I keep mentioning the magic of low melt solder. Now we're gonna flip the board and solder the cap from the back. I'm holding the cap with my finger. Now the flux I'm using is the original genuine Amtech 559 flux, but it looks a bit yellowish. Why? I just found that syringe in my drawer, and it's been sitting there for the past, maybe I would say 2 years. It changed color, but the flux is still 100% usable. Amtech flux is usually clear and it doesn't have a yellow tint, but as it ages, then it changes color. But the functionality is the same. So if you bought a syringe of flux and you left it on your bench for the next 3 years, 4 years, you can still use it. Viscosity may become a bit different. The color may become a bit yellow. But functionality-wise, it's the same. A lot of people ask this question. Should I keep my flux in the fridge? Should I keep it on my bench? Just keep it on your bench. Do not worry about it. Do not overthink it. Beautiful. The joints look beautiful. And if we check the front here, the capacitor is perfectly aligned with the rest. And now, moment of truth. I'm just wondering if PAX will still measure the same at 3.7 volts or 3 point, what was it, 3 point, not volt, ohms, 3.1 ohms. Let me check quick. PAX is reading, yeah, the same, 3.1, 3.2, not a big deal. Now we're gonna turn on the video card and run in case it decided to explode. Then we're gonna have to give the customer our condolences and rest in peace, right? Let's plug our display port. 3 12-volt connectors connected, the adapter, and all we have to do is turn the camera. Maybe I can zoom out. And we want to look at the top screen. Okay? 1, 2, and 3. Oh, I heard a post tone. It looks like the card posted. Yes, 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 amazing. Beautiful. I do see a light on the card as well, right here. Okay. And the card just went out because we do not have the heatsink and fan connected. Amazing, amazing. Amazing. We did it. So let's do a quick recap, a quick summary. We initially did a visual inspection on the board. We did not find anything obvious. No missing components, no blown components, no ripped components, no cracks on the board. Then we measured our 12-volt lines, all 3 of them. We did not have a short circuit. We turned the power supply on. We had 12 volts on each one of the 12-volt lines. We had 5 volts, but we were missing 1.8 volts. Our 1.8 volt rail was missing. But it's not a short circuit because we were measuring 220 ohms on our 1.8 volt line. So that was good news. I inspected the board around the 1.8 volt line, did not find anything obvious, flipped the board, and it turned out that we had a short circuit on one side of the fuse, on back of the board. We injected voltage, and we came to the conclusion that we had a faulty DR MOSFET, a BL DR MOS. We replaced the DR MOS, a cap popped, so we ended up replacing the cap as well, and we replaced the fuse. Card is working. What more do you want? Big Boss is gonna reassemble and test further. We're gonna end the video right here. I hope you enjoyed it. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe. And we'll do something else in the next video.